From Neural Newscast, this is Model Behavior, AI-focused news and analysis on the models shaping our world.
I'm Nina Park. Welcome to Model Behavior. This show examines the intricate ways AI systems are built, deployed, and operated within real professional environments. We look past the headlines to understand the underlying infrastructure and policy decisions shaping the industry.
And I'm Thatcher Collins. Today is July 27th, 2026. On the program today, we are looking at a significant privacy lapse at Anthropic, the evolving economics of the Claude model family, and the intensifying political debate over Chinese AI competition and open weight releases.
We start with a report from Fortune today regarding a major privacy concern for Anthropic users. Over the weekend, a trove of seemingly private conversations with the Claude AI chatbot appeared in public Google search results. These logs reportedly included highly sensitive information, ranging from cryptocurrency wallet keys to full names and home addresses. Thatcher, this seems to stem directly from how the system handles its shared conversation feature, exposing data that users thought was restricted.
That is exactly the core of the issue, Nina. The problem affected chats where users utilized the share feature to create a record of a conversation to show someone else. While Anthropic claims these generated links are not guessable or discoverable unless specifically shared, Reddit users discovered they could pull up a massive list of these conversations simply by using specific search phrases on Google. It wasn't limited to text either. Claude artifacts, which are mini apps and interactive tools, were also showing up in the results.
Anthropic told Fortune they do not share chat directories or sitemaps with search engines. However, they pointed out that once an agent shares a conversation, they are technically making that content publicly accessible, and it can be archived by third-party services. The company appears to have mitigated the search discovery issue since the report went live, but many of those links remain accessible if you already have the URL, which raises serious questions about long-term data persistence.
Nina, I have to push back a bit on the industry's standard response here. This isn't just an Anthropic problem. Forbes noted that a nearly identical issue exposed nearly 100,000 ChatGPT conversations last year, and Elon Musk's Grok has faced similar hurdles. If the share feature consistently creates a unique, indexable URL that users don't realize is public by default to web crawlers, isn't that a fundamental design failure rather than a simple user error? The default expectation of privacy is being broken.
That is a very fair point. Many people treat these chatbots as a private space to think out loud about health, legal, or complex work issues. They expect a shared link to behave like a private document or a shared folder, not a public web page. The fact that the industry's three major players have all made this same mistake suggests we need a more permanent, standard fix for how temporary chat snapshots are handled across the board.
Moving from privacy to performance and pricing, we are also looking at the recent updates to the Claude model lineup. On July 24th, Anthropic officially launched Opus 5 at a price point of $5 per million input tokens and $25 per million output tokens. This follows the June 30th release of Sonnet 5, which is currently in an introductory pricing phase to encourage migration. These prices suggest Anthropic is leaning into the premium reasoning market.
The model routing strategy is becoming the real story here for enterprise users. According to a new analysis from Automation Labs, there is a new default down rule emerging in the industry. Essentially, they suggest using the cheapest possible model that clears the quality bar for a specific task. For the vast majority of business work, such as drafting, coding, and general analysis, Sonnet 5 is becoming the default choice because it claims near Opus-level reasoning at a much lower operating cost.
It is a significant cost gap, Nina. If you default everything to Opus 5 because it is technically the best model, you are potentially paying 5 times more than necessary for every single API call. Opus 5 is increasingly being reserved for only the most complex, long-horizon reasoning or tasks requiring that massive 1 million token context window. Meanwhile, Haiku 4.5 remains the preferred choice for high-volume data extraction or classification where you simply do not need deep nuance to get the job done.
And there is also an Opus 5 fast mode now, which actually doubles the base rate for priority processing. Thatcher, does that actually make sense for a business pipeline, or is that primarily just for interactive consumer apps where latency is the only metric that matters? For many backend systems, doubling the cost for a few seconds of speed seems hard to justify.
It is really designed for interactive work, where a human is sitting there waiting for a response. For batch processing or back-end agents that run autonomously, paying double for speed is generally considered an anti-pattern. The goal for 2026 seems to be sophisticated model-agnostic routing. That means only stepping up to Opus 5 when a task provably fails at the sonnet level. It is all about efficiency and margins over raw power as these systems scale.
While we discuss efficiency, there is a broader debate happening about where that efficiency is coming from. TechCrunch recently covered what they are calling the panic or psychosis over Chinese AI models. The launch of Kimi, the latest model from Moonshot AI, has reignited a fierce debate in Washington about American competitiveness and the future of open source development. It seems the political climate is reacting faster than the technical one.
Nina, the discourse on social media and in DC is getting incredibly heated. Some Chinese models are performing just as well as United States frontier models on certain industry benchmarks, but they are doing it much more cheaply, and often through open weight releases. This has led to reports that companies like OpenAI and Anthropic are lobbying regulators heavily, raising concerns about the potential security risks and safety implications of these open Chinese models being accessible to everyone.
TechCrunch notes that some major industry figures, including those at OpenAI, have been very vocal about this. The primary argument is that AI is so powerful that proprietary models from American labs are the only safe way to maintain control and oversight. But critics, including some on the Equity podcast, are asking if this is truly about national security or if it is just a form of protectionism. They suggest it might be designed to ensure that a few United States labs don't have to compete with free, high-quality open-weight models.
It is a valid question, Nina. If the United States puts across-the-board bans on Chinese open-weight models, it directly benefits the bottom line of domestic proprietary labs by removing low-cost alternatives. We have seen this script play out before with TikTok. The level of panic tends to ramp up the moment you add the word China to the discussion, often to support regulatory positions that these companies already held long before the current competition arrived.
One of the specific examples cited in this recent panic was a claim that Kimi replicated the entire macOS operating system in just 30 minutes. As it turns out, the model just made a graphical reproduction of what the desktop looks like. It was not a functional OS. It really highlights how jumpy the industry is right now, where every new release is treated as a potential end-of-the-race moment without proper verification of the technical claims.
That jumpiness often obscures the real technical breakthroughs happening in the open source community. For instance, a new project called Gigatoken was just released this week. It is a Rust-based tokenizer that claims to be up to 1,000 times faster than the industry standard Hugging Face tokenizers we've been using for years. This is the kind of engineering that actually moves the needle for developers building large-scale systems.
Thatcher, for our listeners who aren't developers, why is tokenization speed so critical for the industry? We usually talk about GPUs being the primary bottleneck in AI performance. So where does the tokenizer fit in? If we have all this computing power, why does the text processing speed matter so much in the pipeline?
It's because tokenization, the process of turning raw text into a format the model can understand, happens on the CPU. If you were processing terabytes of data for training or running massive inference pipelines for millions of users, that pre-processing step can actually become a hidden bottleneck. Gigatoken uses low-level systems programming to process text at gigabytes per second, ensuring the GPU isn't sitting idle waiting for data. It turns a serial bottleneck into a parallel advantage.
It's another clear example of how the boring infrastructure side of AI is finally catching up to the flashy model releases we see every week. Building a stable ecosystem requires these low-level optimizations just as much as it requires the high-level reasoning. That's all the time we have for our deep dive today.
Thank you for listening to Model Behavior.
For more analysis on these stories and the evolving AI landscape, visit mb.neuralnewscast.com. Neural Newscast is AI-assisted, human-reviewed. View our AI transparency policy at neuralnewscast.com.
This has been Model Behavior on Neural Newscast, examining the systems behind the story